Welcome to our deep dive into the fascinating world of sonar. Sonar, which stands for sound navigation and raying, is a technology that has revolutionized the way we explore and understand underwater environments. From mapping the ocean floor to detecting submarines, sonar plays a crucial role in both scientific research and military operations. In this video, we'll uncover how sonar works, its history, and the many ways it impacts our daily lives. Let's start by understanding the basics of what sonar is and why it's so important in the modern world. Origins of sonar date back to the early 20th century, when scientists and inventors sought ways to detect objects underwater. The sinking of the Titanic in 1912 spurred interest in developing technologies to prevent such disasters. Early sonar systems were primitive, but they laid the foundation for the sophisticated devices we use today. Over the decades, sonar has evolved from simple echo-sounding devices to complex systems capable of detailed underwater imaging. This evolution has been driven by advances in technology and the growing need for underwater exploration and safety. At its core, sonar operates by sending out sound waves and listening for their echoes. When these sound waves hit an object, they bounce back to the sonar receiver. By measuring the time it takes for the echo to return, the system can determine the distance to the object. This principle is similar to how bats navigate in the dark using echolocation. Sonar systems can be active, where they emit their own sound pulses, or passive, where they simply listen for sounds made by other objects. This basic concept underpins all sonar technology. There are two main types of sonar: active and passive. Active sonar sends out a pulse of sound and listens for the echo, making it ideal for detecting the location and distance of objects. Passive sonar, on the other hand, does not emit any sound. Instead, it listens for noises produced by other sources such as marine animals or submarines. Each type has its own advantages and is used in different situations. Active sonar is great for mapping and navigation, while passive sonar is often used for surveillance and stealth operations. Interestingly, sonar isn't just a human invention. Many animals have developed their own versions of sonar, known as echolocation. Bats, dolphins, and some species of whales use sound waves to navigate and hunt in their environments. By emitting clicks or calls and listening for the returning echoes, these animals can detect prey, avoid obstacles, and communicate with each other. Studying these natural sonar systems has inspired many technological advancements in human-made sonar devices. Sonar technology has played a significant role in military operations, especially in naval warfare. Submarines rely on sonar to navigate underwater, avoid obstacles, and detect enemy vessels. During World War II, sonar was crucial for detecting submarines and protecting ships from underwater threats. Today, advanced sonar systems are used for surveillance, mine detection, and anti-submarine warfare, making them indispensable tools for modern navies around the world. Oceanographers use sonar to map the seafloor, study underwater features, and monitor marine life. By sending sound waves to the bottom of the ocean and analyzing the echoes, scientists can create detailed maps of underwater landscapes. This information is vital for understanding ocean currents, plate tectonics, and the habitats of various marine species. Sonar has opened up new frontiers in marine science, allowing researchers to explore areas that were once inaccessible. One of the most important uses of sonar is mapping the ocean floor. Multi-beam sonar systems can scan wide areas, producing high-resolution images of underwater terrain. These maps are essential for navigation, laying underwater cables, and studying geological processes. The data collected by sonar has revealed underwater mountains, valleys, and even shipwrecks, providing valuable insights into the hidden world beneath the waves. Fishermen have long used sonar to locate schools of fish and improve their catch. Fish finders, a type of sonar device, send sound waves into the water and display the location of fish on a screen. This technology has made fishing more efficient and sustainable by helping fishermen target specific species and avoid overfishing. Sonar has become an indispensable tool for both commercial and recreational fishing around the world. Sonar is also used in search and rescue operations to locate objects or people underwater. Whether it's finding a sunken boat, locating a lost diver, or searching for evidence in criminal investigations, sonar provides rescuers with a powerful tool to see through murky waters. The ability to quickly and accurately scan large areas underwater can make the difference between life and death in emergency situations. Did you know that sonar principles are used in medicine? Ultrasound imaging, a common diagnostic tool, relies on high-frequency sound waves to create images of the inside of the body. This non-invasive technique helps doctors monitor pregnancies, diagnose conditions, and guide surgical procedures. The development of ultrasound technology was inspired by sonar, demonstrating how innovations in one field can lead to breakthroughs in another. Archaeologists use sonar to discover and study underwater ruins, shipwrecks, and ancient artifacts. By scanning the seabed with sonar, researchers can identify objects buried beneath layers of sediment. This technology has led to the discovery of lost cities, sunken ships, and other historical treasures, shedding light on our past and preserving cultural heritage for future generations. Environmental scientists use sonar to monitor the health of aquatic ecosystems. By tracking fish populations, mapping habitats, and detecting pollution, sonar helps researchers understand the impacts of human activity on the environment. This information is crucial for developing conservation strategies and protecting endangered species. Sonar has become an essential tool in the fight to preserve our planet's natural resources. Autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, use sonar to navigate and explore the ocean depths. These robotic explorers can operate in dangerous or inaccessible areas, collecting data and performing tasks without risking human lives. Sonar provides these vehicles with the ability to see underwater, making them invaluable for scientific research, oil exploration, and underwater construction. Building structures underwater, such as bridges, tunnels, and pipelines, requires precise knowledge of the seafloor. Sonar is used to survey construction sites, monitor progress, and ensure the safety of workers. By providing real-time data on underwater conditions, sonar helps engineers make informed decisions and avoid costly mistakes. This technology is essential for the success of complex underwater projects. Sonar is a vital tool for navigation, especially in environments where visibility is limited. Ships and submarines use sonar to detect obstacles, avoid collisions, and find safe passages through shallow or treacherous waters. Modern navigation systems often combine sonar with GPS and other sensors to provide accurate and reliable guidance, ensuring the safety of vessels and their crews. Sonar has greatly enhanced our understanding of marine life. Scientists use sonar to study the behavior, migration patterns, and population sizes of various species. This information is essential for managing fisheries, protecting endangered animals, and maintaining the balance of marine ecosystems. Sonar allows researchers to observe creatures in their natural habitats without disturbing them. While sonar is a powerful tool, it does have its challenges. Factors such as water temperature, salinity, and underwater obstacles can affect the accuracy of sonar readings. Additionally, some marine animals are sensitive to sonar signals, which can disrupt their natural behaviors. Scientists and engineers are constantly working to improve sonar technology and minimize its impact on the environment. Sonar is not just for detecting objects, it's also used for underwater communication. Submarines and underwater vehicles use sonar signals to send messages and coordinate movements. This form of communication is essential in environments where radio waves cannot travel, such as deep underwater. Advances in sonar communication are enabling new possibilities for exploration and collaboration beneath the waves. Oil and gas industry relies on sonar to locate underwater resources and plan drilling operations. By mapping the seafloor and identifying geological formations, sonar helps companies find new reserves and minimize environmental risks. This technology is critical for the safe and efficient extraction of resources from beneath the ocean floor. Sonar is a valuable tool for studying the effects of climate change on the oceans. Scientists use sonar to monitor melting ice, track changes in sea level, and study the movement of ocean currents. This data helps researchers understand how climate change is impacting marine environments and informs efforts to protect vulnerable ecosystems. Underwater mining operations use sonar to locate valuable minerals and monitor excavation sites. By providing detailed images of the seafloor, sonar helps companies extract resources efficiently and safely. This technology is opening up new opportunities for resource extraction in areas that were previously inaccessible. Sonar has played a key role in discovering and exploring shipwrecks around the world. By scanning the ocean floor, researchers can locate sunken vessels and study their remains. These discoveries provide valuable insights into maritime history and help preserve important cultural artifacts for future generations. Scientists use sonar to study underwater volcanoes and monitor volcanic activity on the ocean floor. By mapping the shape and size of these volcanoes, researchers can better understand the processes that shape our planet. Sonar data also helps predict eruptions and assess potential hazards to nearby communities. Operating in ice-covered waters presents unique challenges, but sonar is up to the task. Icebreakers and research vessels use sonar to navigate safely and study the thickness and movement of sea ice. This information is critical for understanding polar environments and supporting scientific missions in some of the world's most extreme conditions. Laying submarine cables for internet and communications requires precise mapping of the ocean floor. Sonar is used to identify the best routes, avoid hazards, and monitor the installation process. This technology ensures the reliability and safety of the global communications network that connects people around the world. Underwater robots, or remotely operated vehicles (ROVs), rely on sonar to navigate and perform tasks in challenging environments. These robots are used for everything from scientific research to underwater repairs. Sonar gives them the ability to operate autonomously and complete missions that would be too dangerous or difficult for humans. Similar to underwater robots, drones equipped with sonar are transforming ocean exploration. These drones can cover large areas quickly, collecting data and images for scientific studies, environmental monitoring, and resource management. Sonar technology allows them to operate in complete darkness and navigate complex underwater landscapes. Sonar is often used alongside underwater cameras to capture images in environments where visibility is poor. By combining sonar data with photographs, researchers can create detailed maps and 3D models of underwater sites. This approach is especially useful for documenting shipwrecks, archaeological sites, and marine habitats. With advances in mobile technology, sonar-based navigation apps are now available for recreational boaters and divers. These apps use sonar data to provide real-time information about water depth, obstacles, and points of interest. This makes navigation safer and more accessible for everyone from professionals to hobbyists. Ports and harbors use sonar to monitor marine traffic and ensure the safe movement of ships. By tracking vessel positions and detecting underwater hazards, sonar helps prevent accidents and maintain efficient operations. This technology is essential for managing busy waterways and supporting global trade. Inspecting and maintaining underwater pipelines is a challenging task. Sonar is used to detect leaks, monitor structural integrity, and guide repairs. This technology helps ensure the safety and reliability of pipelines that transport oil, gas, and other resources beneath the sea. Artists and designers are using sonar to create unique underwater installations and sculptures. By mapping the seafloor and visualizing sound waves, they can produce artworks that interact with the marine environment. Sonar adds a new dimension to creative expression beneath the waves. Sonar technology is making waves in the world of underwater sports. Divers and athletes use sonar devices to navigate, locate targets, and enhance safety during competitions. This technology is helping to push the boundaries of what's possible in underwater exploration and recreation. Educational underwater drones equipped with sonar are introducing kids to the wonders of marine science. These drones allow young explorers to observe underwater environments, collect data, and learn about sonar technology in a fun and interactive way. This hands-on experience inspires the next generation of scientists and engineers. Some museums are taking their exhibits underwater, using sonar to guide visitors through submerged galleries. These unique attractions combine art, history, and technology, offering a one-of-a-kind experience for divers and snorkelers. Sonar ensures that visitors can safely explore and appreciate these underwater treasures. Aquaculture farms use sonar to monitor fish stocks, track growth rates, and optimize feeding. This technology helps farmers manage their operations more efficiently and sustainably, ensuring a steady supply of seafood for consumers. Sonar is playing a key role in the future of underwater agriculture. Renewable energy projects such as offshore wind farms and tidal power stations use sonar to survey sites and monitor equipment. By providing real-time data on underwater conditions, sonar helps ensure the safety and efficiency of these clean energy sources. This technology is supporting the transition to a more sustainable future. Tourism operators are using sonar to enhance underwater experiences for divers and snorkelers. By providing real-time information about marine life and underwater features, sonar makes exploration safer and more enjoyable. This technology is opening up new possibilities for adventure and discovery beneath the waves. In the aftermath of natural disasters, sonar is used to assess damage, locate debris, and support recovery efforts. Whether it's a hurricane, earthquake, or tsunami, sonar provides emergency responders with the information they need to act quickly and effectively. This technology is a vital part of disaster response and recovery. Filmmakers use sonar to plan and execute underwater shoots, ensuring that cameras capture the best angles and avoid obstacles. This technology allows for the creation of stunning documentaries and movies that showcase the beauty and mystery of the underwater world. Museums and researchers use sonar to locate and recover underwater artifacts. By providing detailed images of the seafloor, sonar helps identify objects of historical and cultural significance. This technology is essential for preserving our shared heritage and uncovering the secrets of the past. Innovative sonar devices are being developed to help visually impaired individuals navigate underwater environments. These devices translate sonar data into tactile or audio feedback, enabling users to explore and enjoy the underwater world safely. This technology is making underwater experiences more inclusive and accessible. Sonar technology continues to evolve, with new advancements on the horizon. Researchers are developing more sensitive and accurate systems, as well as integrating artificial intelligence to interpret sonar data. These innovations promise to unlock even more possibilities for exploration, safety, and discovery in the underwater world. From its humble beginnings to its modern applications, sonar has transformed our understanding of the underwater world. It's a technology that bridges science, industry, and art, touching nearly every aspect of our lives. As we look to the future, sonar will continue to play a vital role in exploration, safety, and innovation. Thank you for joining us on this journey beneath the waves, where sound becomes sight and the mysteries of the deep are revealed.